This is section 6, part 2 on chapter 1, solving absolute value inequalities. So we have to build off the compound in part 1, and then also combine that with absolute value rules that we learned in solving absolute value equations. So, graphing absolute value inequalities. Okay, if we have something like, let's see, the absolute value of x is less than 3. Okay, that means we're saying the distance x is from 0 has to be less than 3. So if we were to think about that, 0 is here. We want the distance to be less than 3 out. So if I go equal to 3, I'd be at 3 and negative 3. We want everything less than that. So those aren't included. But anything that's less than 3, so like negative 2, negative 1, 1, 2, those are all less than 3. So that shaded region would be in the middle, okay, because the distance is less than. If we had to say x is greater than 5, okay, we have 0, 1, 2, 3, 4, 5. We want the distance, okay, anything farther away than 5 is. Okay, so 5 wouldn't be included, but anything that's farther away from 5, so more than 5 away, or anything that's farther away than negative 5, so more than 5 away. So that's what that graph will look like. So hopefully those graphs look familiar from the compound one. Since this is in the middle, it's an and. Okay, there's an overlap. Now, you could always tell that if the absolute value is by itself what this sign is. If it's a less than or less than or equal to, it's an and. If it's greater than, then it's an or. And I usually think of this as greater than, so I remember that as greater, and then less than as and. Make sure though the absolute value is by itself first. Alright, so let's look at a problem. We have absolute value 6y minus 5 is greater than or equal to 13. So greater is or. So we know that we're just going to graph both of them. We don't have to worry about an intersection. So we have 6y minus 5 is greater than or equal to 13. Now just like when we did in equations, we're going to have two inequalities to solve. However, when we write the negative one, just like when we divide by a negative, we have to flip that inequality sign. So 6y minus 5 is greater than or equal to 13, or 6y minus 5 is less than or equal to negative 13. And then we solve them separately. So add 5, divide by 6, add 5, and divide by 6. Oops, 6. And let's see. That goes in there. What's 2/6 left, or 1/3? Okay. So then we graph those on our number line. Negative 1 and 1/3 is smaller, so make sure that's first. 3 is bigger. It says greater than or equal to 3, so make sure that goes above your 3. Closed in and greater is to the right. Less than or equal to negative 1 1/3. Again, closed in, less than is to the left. Go ahead and pause the video and try this problem. Alright, so 5z plus 2 is less than or equal to 17. The other one, remember, flip that inequality. Oops, I didn't flip it. I said it and I didn't flip it. So that's greater than or equal to negative 17. Since the original one, when the absolute value is by itself, is less than, that is an and. So make sure that your graph has some kind of overlap. If it doesn't, then there would be no solution. So solving this, z is less than or equal to 3. Well, let's see, 19. let's see, 5 goes into 19 3 times. That's 15, so there'd be 4 left over. Alright, graph these. Oops, I did not mean to erase the whole thing. -3 and 4/5 is smaller, so make sure that's first. 3 is larger. Let's see, greater than or equal to 3, or sorry, less than or equal to 3. That's to the left. Greater than or equal to -3 and 4/5. That's to the right, so that's good. They'll overlap then in the middle. Perfect.